All right, so it is 12:30, so we're going to get started. First of all, I hope everybody here is having an amazing Ignite. And for those who are flying from out of town here to attend this event, extended welcomes to you. All right, so I hope none of you guys are missing lunch for this session, and if you are, I hope you get more out of this session than you are going to get out of lunch. All right, it's hard to compete with food. So my name is Vin, and I am a program manager on the SQL Server team. Over the past few years, I have been working with SQL Server on Linux, and now working with SQL Server in containers as well. All right. So in this session, we're going to cover running SQL Server in containers. Actually, before I even get into the session, typically when I give this talk, I have several different types of audiences, some that which come from more developer-centric backgrounds, some come from a more data-centric background, such as being a DBA. So actually, just for a raise of hand, so I can, which would help me provide this presentation to you, who comes from a more developer-based background? Please raise your hand. Awesome, that's a lot in the room. Who comes from more of a DBA data-based background? Oh, it's like 50-50. I swear some people raise their hand twice. Maybe you do everything in your company. You know, we have a lot of those as well. So in this session overview, we're going to talk about using SQL Server in containers. Who has tried SQL Server in containers? Put your hand up. Okay, a little less. So that's going to change really quick. We're going to show you how easy it is in this session, how it's going to really help you with app development. Right? We're also going to go into application development and what that means for your development environment. We're going to go through testing, as well as applying migrations to your SQL Server, as well as having SQL Server in containers in your CI/CD pipelines, and last but not least, applying these type of migrations if you're running SQL Server in Kubernetes. Right? So for each one of these sessions, for each one of these bullet points here, we're going to have a demo. I'll also have some slides to help reiterate some of these concepts. So don't worry if you don't get it just by looking at the demo alone. I will try my best to explain this to you. Right. Before we talk about containers, one thing that Microsoft, especially the SQL Server team, we're really committed to is providing a platform of choice. Now, for many of you may know, SQL Server 2017 was the first version of SQL Server that's multi-platform. And what we mean by that is we've offered SQL Server on Ubuntu, Red Hat, SUSE, as well as now having it offered in a containerized format. So yesterday, we actually also made an announcement that we now officially have SQL Server and Red Hat containers. Right. And one question that we're constantly getting because we're providing SQL Server on all these different platforms, is it the same SQL Server? And the answer is yes. So whether you're using temporal tables, dynamic data masking, role-level security, or any other features that's configurable with T-SQL alone, this will work inside a container as well. Right. So with that, let's get into SQL Server containers. Right. So over the last year, I've talked to many different customers, and customers are adopting SQL Server and containers for many different purposes. Right. From local development and testing to automation and DevOps pipelines, as well as deployment with container orchestrators such as Kubernetes. Right. So here are a few of the reasons why our customers are coming to us asking for SQL Server and containers. The first is it's isolated and consistent. What I mean by that is every time SQL Server starts up inside a container, it is started in its own container. There's no other processes in that container alone. And which means that every time you start it, there's a consistent behavior. And it is also portable. So if you were to start up SQL Server across different machines, as long as you have Docker Engine installed, SQL Server is going to start up in that same behavior repeatedly every single time. Whether you choose to build on top of that SQL Server container or run the SQL Server container from our repository straight up. It is also very easy to use, and it is easy for starting and stopping. And my favorite part is there's no installation involved. For many of the developers in this audience today, you may know that, okay, well, to get my development environment set up, I want to have to install these dependencies and these services running. With SQL Server inside containers, all you have to do is download and start running it immediately. And now I have one thing that I realize, SQL Server in containers is also really good for demos. All right. So to get started with SQL Server in containers, it really just takes two commands, right, to get started. First is a pull command, and here you'll see that I have a Docker pull SQL Server from the Microsoft Container Registry. And after the semicolon there, what you'll see is the tag, and that is the version of SQL Server that you want to pull. If you specify no tag, The default behavior that our team has decided is that you will get the latest generally available version of SQL Server. So for example, if I did not have the 2017 latest tag on here, you will end up getting SQL Server 2017 CU 11, not 2019, because 2019 is currently still in preview, right? And to start running it, to actually run this container once you have pulled it, you will use Docker run. At a minimum, the SQL Server container requires 2 environment variables. One is that we require you to set the EULA, and the second is we also ask you to enter SA password, right? You can also configure additional environment variables. For example, for those who work with SQL Server, you may know that SQL Server agent, when you install it, it is not started by default. Here you can enter an environment variable, for example, to start up SQL Server agent at startup time. The next thing you see here that's slightly cut off and wrapped around from the screen is the -P. That means port. The 1600 and 1433 indicates that on my local host machine, I want to run SQL Server listening on 1600. So if I'm using any other tool, for example, SSMS, and I'm connecting to SQL Server with this Docker run command, I'm going to run to localhost 1600. And 1433 is the port that's listening inside the container. And last but not least, we have to specify the image that we want to run. With that said, let's just show this in action. All right, so here's my screen. Just going to get this copied over. So first, I'm going to do a Docker pull of SQL Server. And I already have it pre-pulled in advance because I don't want everyone sitting here, depending on the network, having this pulled down. And once I have it pulled, I'm going to run it. All right, so I'm going to just copy and paste this here. And you can see that I'm running Docker run, again, with the 2 environment variables that's required to get SQL Server started. First, accepting the license, and the second, a password. Right. So I'm going to get that started, and there you go. SQL Server is now started on my machine, in a container without any installation. So let's just see that running. So we can see there's a container ID here. This is the ID the Docker gives containers. The image that it is currently running, the command within the container in which what is the process that's currently running in here. It's a little cut off, but it would say opt msql bin SQL Server process. It's been up for 10 seconds and is currently listening on 1600. So let's just open up a tool to connect to this instance. So this is a tool called Azure Data Studio for those who have not worked with this. This is our new tool. We just announced this yesterday. This is a cross-platform tool that works on Mac, Mac OS, Linux, and Windows. So with that said, let's connect to the instance that we just provisioned. So mind you, I'm using 1600. Again, this is the port that I told the container to run on. And I'm going to connect. Awesome. I'm connected. So you can see that there's a computer name here. So SQL Server is running some T-SQL scripts in the background to populate this dashboard that you see here. And you can see that it actually matches that of my container ID. Right? And that is how easy it is to get SQL Server started on inside a container. OK. So that's really good if you want to get a SQL instance of SQL Server up for some ad hoc queries or to run some quick tests and for development, right? So as we saw, once SQL Server has started up, you can connect to it and develop with it with any tool that you have been before. So for example, if you are using SQL CMD or other CLI tools such as BCP, MS SQL CLI, or SQL package, those will work with SQL Server in a container just like it would SQL Server on Windows. This also works with graphical user interface tools. So in the bottom, you can see that I just showed a demo of me connecting with Azure Data Studio, SQL Server Management Studio, SSMS, as well as SSDT. All right. All right, so let's take a look at what SQL Server containers look like and what they could do for your development environment. Right. So if you look at back then, it was very common to see shared development resources and servers as well. And this causes a problem where you can see that a subset of developers are potentially hogging more resources and then affecting other developers' use of time. What's also possible is that a mistake from one developer can actually bring down the entire development environment. Now, as someone who's running a project, you might think, okay, well, at least I didn't bring down production, because that would have been really bad. But if you think about it, if one development brings down a development environment that's shared between, that is a resource that's shared between 100 other developers, that's actually quite expensive, right? And last but not least, one thing that you still see that's very common today in a lot of companies is that folks and developers are taking a lot of time provisioning resources. And this could take a lot of time. And if you get it wrong, this may require additional support as well to get your application running, right? Which brings me to the next point, sharing databases. It's probably something you shouldn't do. You can imagine there's two developers sharing a database or a database server, and one of them is writing to it, changing the schema as the other one's trying to do some development on it. You kind of get into a situation where it doesn't, they're stepping on each other's toes. And it's also not very representative of what's going to be running in production either. So which comes to the point where we could really simplify some of the points I mentioned earlier with SQL Server and containers. Right? Instead of spending the time to install a SQL Server instance, we could spin one up. And we just saw how easy and quick that was. Right? We spin up a SQL Server, we connected to it, and there was not many problems from there. Right? So, and then you can connect to that container with your application, right? And do any app development that's required. Right? So with that, let's get into some application development with containers. So to get started, I'm just going to show a very basic, I'm going to set this up with a scenario. Right? So here I have a very basic application. It is a flight membership application that provides our flight attendants information about our premium members. Right? So it has a first name, a last name, member ID, phone number, email. It's just like a very basic user table. Now, one day my manager comes to me and says, hey, Vin, I know you're new on the team, but I really need you to fix this. Please ensure that our flight attendants don't see the phone number and email. So just make sure that's masked. Right. So the first thing the first thing we do as a developer, I actually have to go get the code. Right, so here on the very left, as a new developer, I'm going to set up my development environment. The first thing I'm going to do is go to source control and grab all the code. And you can see that I have all the code that represents the components on my left. Right? Now, it's also very important and critical for me that I have the ability to start up my application that mimics, that has all the services, and it mimics something that's in production, which means if my application has multiple components, such as a backend, like a REST API, a front end, and a database service, I need to start all those up in a very easy fashion. And this is where a tool called Docker Compose comes in. Right? Who's familiar with Docker Compose? Okay. Neat. So for those who don't know, so Docker Compose is a tool that enables you to run multiple containers at the same time and connect it over a network so that they can communicate with each other. So notice how earlier I was starting up a single instance of starting a single SQL Server instance in a container. You can imagine that managing a front-end piece, a back-end piece, and a database piece, all with Docker commands, could get a little bit repetitive. Right, so, which is why we have a Docker Compose file. Right, so I'm going to walk folks in this room over this file. So don't worry if this just seems like a fire hose being blown at you. Right, so Docker Compose is going to have it's going to define services, and each service is backed by a container. So here we can see that we have 4 components of our application. We have a web app component, we have a database component, we have a front-end component, which is our web page, and we have a migrations component. So let's just start from the very top. We have a web app. This is going to build our web app component. First, it's going to gather all the dependencies, it's going to compile and build the app, and then it's going to move the output of that into a container and run it. Now, the details of how I build that is not that important for this talk, as we're going to really focus on the database aspect. So the second service that we're going to run is the database component. So you can see here that the image I'm choosing to run is SQL Server from mcr.microsoft.com. And the environment variables I'm going to choose to start off, I'm going to run is having an SA password accepting the EULA. And in this case, I'm going to add one environment variable called MS-SQL agent enabled, which starts at the agent process. So notice how similar this looked to our previous Docker run command. Right? It's actually quite similar from that regard. And I'm going to have this listing on 1500. So the next component is our front-end component. This front-end component is just the web page, similar to the back end. It's not very important of how we build this. We're going to focus more on the database part. Now, the last application, notice how we have a back-end component, which is going to read from our database. But the image that we choose to run is the vanilla SQL Server image, which means it won't have any schema, it won't have any data. So in order for our application to run, we actually have to apply a migration. Now, I'm going to go into migrations shortly in the next section here, so I'm not going to dwell too much on the slide. But think of it as now, this migration applies all the schema and data necessary for my application to run. As mentioned earlier, we can start all 4 of these containers with a single command, so let's do that. So I'm going to do a Docker. So I am in the context of my root is in the context of my source code right now. So the first thing I'm going to do is build. And I'm going to build all the containers required, that requires building to run this application. And the second one is up. Right? So you can see here really quickly, and I'll scroll up in a bit because this is going to come, is that it's going to spin up all 4 containers. And here what you see on the screen now is the SQL Server log at startup time. Right. What you may also see is that there's this flyway migration. It's actually applying the migrations to the SQL Server so that my app can start. With that said, let's go open a new tab. Your localhost. And here, immediately I spun up my back end, my front end, and SQL Server required with the data applied to it. And here I have an app that similarly represents what is in production. So here again, I have first name, last name, member ID, phone number that's currently unmasked, that's currently still showing the phone number and email, which I am tasked to fix, right? So similar to how I just used Docker Compose to start up all 4 containers at once, and you can notice how SQL Server fits in this picture, I could also do something very similar for test, where I'm going to spin up a database container using Docker Compose. I'm going to apply the migrations to it, and then I'm going to run a series of tests against that SQL Server instance, as specified in my top service of test app. Right? So let's go do that as well. First, I'm going to exit this, and then I'm going to press Docker Compose down. And what Docker Compose down does is I'm just cleaning up all the containers and removing those containers from what I just ran. All right. So let's go look at. Let's grab the next set of scripts. So here I'm using, again, Docker Compose, but this time I'm entering a specific file. By default, if you just run Docker Compose, it's going to look for a Docker Compose YML file. Now, if you want to specify if you have multiple Docker Compose files, you're going to need to pass in the file flag so that it knows what file to read from. Again, I'm going to build this Docker Compose file, ensure that I have all the containers that I need. Then I'm going to Docker Compose up. So first, we're going to, again, start up SQL Server. And again, you can start seeing some of the benefits that we have here because we are using every time we start up SQL Server, it's starting in a reliable state. It is in its own environment. It's isolated. Right? So you can see that the migration, after it applied, it exited. And now my tests are going to start running. Right? And here I have a bunch of application code tests that used a new SQL Server container that started up for the test, and we can see that the tests have run and the container itself has exited. Right? So let's just stop that. And I'm going to clean up the resources because I no longer need it. All right. So what we just saw was 2 demonstrations of using how SQL Server can be used, SQL Server in a container could be used in your application development environment, right? As well as using SQL Server in containers for tests because it starts up in a reliable manner every single time, right? So just to help folks understand what we were trying to achieve with those Docker files in case you weren't able to grasp all those, grasp the whole concept of Docker Compose files. Here's what we were trying to do. First, in our Docker Compose file, we specified that we want a database. And then we want to have another container that acts as a service and applies the schema. After it applies the schema, that container that applies the schema goes away. And then we have our back-end application connect to that SQL Server instance. And then we have our front end connected to the back-end app. And that's what we've seen. And the user from there connects to the front-end application. And that's what we see in our web app. Right. Similar for test, we spin up a SQL Server in a container. We apply the schema. And then we apply the test. And once the tests run, it is completed. Now, notice in both the cases, we had to run a migration to that database, which gets us into the next section. Because when we pull a Docker SQL Server image from MCR, our Microsoft Container Registry, it doesn't have any schema to it. Right? So we have to find a way to apply that schema in the data in order for our application to run. Right? So in our minds, typically when we think as developers, we think that, hey, typically I have an application and I have a database, right? I have an application database. So you might think, in our minds, it could be a simple understanding as simple as, hey, I'm just going to run a bunch of .SQL files against this database, and my application is going to run. And you know what? And most of the time for development environments, or if your application is really simple, that's going to work. However, your environments typically look like this, all right? So where you have multiple developers, multiple environments, and if you're running .SQL files ad hocly or manually, you're going to start asking questions. What state is the database in on this machine? Has this script already been applied or has it not? And it sounds like there's been a quick fix in production. Has it been applied to any other environments? And how do I set up a new database instance for development and testing? And how do I repo a bug, right? So, which gets to a point where you might think, okay, well, you end up with something like this. By the way, I got these two comic slides from FlyAwayDB because they explain this really well, just for creds. And so with software, we have source control, right? And it's really easy to download the code, get started with it, build on top of it, repo any bugs, because we know the exact version, right? However, if you are applying SQL script ad hocly, you're going to enter a situation of not knowing what version your database is on, right? So versioning databases is good, right? So that's something that you should do. You should treat your database like you would your code, right? So you could actually have things such as reproducible builds, consistent continuous integration environment, and you could have a consistent testing environment as well. And there are some tools that could help with that. SQL package, which builds a model of your database and then generates the necessary SQL to apply to your SQL Server instance. There's also open source solutions such as FlyAway and Liquidbase. And in my demo, I'm using FlyAway, which are both database source control files. And I'll explain to you that in the code, and I'll show you how this works in a bit. Now, I want to make one point here, is that these tools alone aren't going to solve all the problems. You need the right processes in place. What we've seen in a lot of companies is that they have the tool and they think that, oh yeah, I have this awesome tool, it's going to make all my problems go away. So it's also, that's actually not the case, because there's going to be situations where you're going to apply an ad hoc SQL script here or there to fix the problem. All right? So you need the right processes in place, backed by the right technology. So with that, let's get into let's go take a look at what these containers look like. Right? So back to my screen. Here, I'm going to look at my FlyAway folder. And let's look at a very simplified Docker Compose file where I only have the migration container as well as the SQL Server container. So here, I have my SQL Server container. Again, it pulls SQL Server from Microsoft Container Registry. It starts it with the correct password, accepts the EULA, and is listing on 1433. Right? And on top, I have a migrations container. And this container, what it's going to do is it's going to pull the FlyAway utilities. And the FlyAway utilities, all it does is it applies a bunch of SQL scripts against your SQL Server instance. So how that works is in our Docker Compose, we said that we have a volumes. What volumes does is it mounts the local directory. Here I have .sql, so you can see that it is in the context of this directory here into Flyway SQL, which is what is inside inside the Flyway container. So it's going to copy all these .sql files into that Flyway SQL folder. And then the entry point is, meaning the entry point and command are two of them that says, hey, upon starting this container, what do I want to do, right? So I have this this little script that says wait for it. Because SQL Server takes time to start up, I have to wait for SQL Server to get to a point where it's actually accepting connections first. And that's what wait for it does. And after the instance is up and taking connections, I'm going to run a command called Flyway, which is just the name of the utility that I'm going to run. And I'm going to run the command migrate. And here are a bunch of options in which I could do for my migration. With Flyway, I can actually apply a very specific version of my schema. Or I can just, if by default, if I don't have a target, it's going to apply all the SQL scripts up to the latest point. So here, what I was doing is first, I'm creating some logins, and I'm creating the user table, as mentioned here. And in the second one here, version 1.1, as seen by the path, is I'm entering some data, some dummy data, right? So with that said, let's go ahead and run this container, just to show all. So again, so building was complete, and let's run it. So again, it's going to start up two containers. One of them is my SQL Server instance, and the other one is the migration. Neat. So here you can see that SQL. So if I look at the very top, just to walk you guys through what's actually happening the second I hit, I'm actually using Docker Compose. You can see that here, I'm creating a network, which is the name of the network that's going to actually design for both these containers. And I'm going to start up a database container as well as a migrations container, right? So immediately they start at the same time. However, as I mentioned, I have this script called wait for it. And it's going to wait for up to 30 seconds for the database container listing of 1433 to start up. And here you can immediately see that SQL Server is attempting to start up, right? So you can see that starting up. And at some point, the migrations container can say that, hey, look, 1433 is actually up and listening. Let's go ahead and start running our migrations. At that point, you can see that first it does a validation to ensure that all the .sql files that you want to apply can be applied, and then it'll go ahead and it's going to apply it. So you can see that it was successfully applied 2 migrations to this database. So let's spin this down. But notice here I have three SQL files, and I only applied 2 of them. That's because in my Docker Compose file, I have only chosen to apply 2. Right? Now, let's go revisit our original problem. All right? At this point, as a developer, I have my local environment running. I could run the test that's currently checked in as well. And the original task that my manager, my boss had told me to go do is, hey, Vin, I want you to go ensure that the phone number and the email is masked. So let's say sometime later, I come up with a fix. And the fix is as simple as 2 lines in SQL Server. I'm going to use dynamic data masking as a feature. And this is going to mask all the phone numbers and the emails that's necessary, as simple as 2 lines. I don't have to write any other application code. I'm going to do this all with just SQL. So first of all, I'm going to have to just make sure that this is running properly in my local environment. So let's see this running locally running properly in my local environment and applying this fix. So before, in my migrations, again, I was only applying target 1.1. Let's remove this target and apply everything that's in this file to see that to see if my SQL fix works. So I'm going to go back here, and I'm going to just type in Docker Compose build. So I'm going to build all the containers necessary just in case, and then I'm going to run Docker Compose up. So again, this time I'm starting my database container, my migrations container, as well as my 2 application containers. And it's starting up. So here, this time, you notice how before I was only applying 2 migrations. Now I'm applying all 3, right? So if you go here, so if I go to my application, my local host, I can now see that my fix indeed worked, right? I can see that the phone number is 0 and the emails are masked. So it looks like I'm super excited at this point, and I go to one of my colleagues and say, all right, let's go check this in. He's like, whoa, hold on. Before you check this in, make sure you run some tests. Great. So I'm going to exit out here. And again, I could rerun those tests I had before to ensure that I don't have any regressions. So notice how every single time I'm just reiterating the point, I'm starting a new SQL Server instance. And I'm applying the migrations, which enables me to have a very consistent point. Right? So let's go back to our script here. So let's run our tests. So let's first, again, rebuild our tests. And let's run our test again. Right. So again, SQL Server starting up. I'm going to have to keep saying that, SQL Server starting up, because that's what's showing on the screen. I have 3 migrations applied to my tests. And it's going to take a moment for my test driver to actually get started here. So there you go. My test driver is now up, and it's going to start running the tests. And I can see that all my tests continue to work. Right? So at this point, I'm thinking, all right, let's get this checked in. And I'm going to put this through my CI pipeline, right, to ensure that this works with all the other changes that my colleagues have in place as well. Oh, whoops. What was I doing? Let's down, make sure that this is done. So the way our CI/CD pipeline is going to work is first I'm going to check this into our source control, check this change in. So I'm going to do a git commit. Oops, that's not what I meant. And I'm going to say demo, right? And then I'm going to push this in, right? Push this to my repository. It is now pushed in. And once the second my repository has a change, my continuous integration pipeline is going to pick up and detect that, hey, there was a trigger. Someone just checking some code. Let's start running the integration. So if I go to a pipeline, so this is Azure DevOps, formerly Azure VSTS, right? So every time I check something in, it is going to attempt to run it's going to kick off a new build. Right, so let's just refresh this to see that. So indeed, you can see this little time icon here. Might be a little small for the folks in the back. But if I were to click on this, it is actually attempting to start a job. Right, and it's going to start integrating the code, ensuring that the app still builds, ensuring that the tests still run before I can actually do a final check-in and push this or deploy this into production. Right. So this process takes about 4 to 5 minutes. Let's just walk through the steps of our CI pipeline to show you how what SQL's role is playing in that area. So our pipeline is defined by a Azure Pipelines YML file, which is also checked in to our GitHub, so that when Azure Pipelines decide to pick this up, it knows what the steps it wants to run are, right? So for starters, it is going to run my build in a Ubuntu 16.04 machine. It's going to have some environment variables to ensure that I have all my application. It can build my applications as well. So let's start going down the steps. The first step I'm going to do is set up my Go workspace, because this application is written in Go. The second thing it's going to do is going to grab some dependencies and ensure that it could build. So you can see that here I'm building my application. See that if I did indeed make an application change, nothing has broken. Then I'm going to start trying to attempt to do a test on this new application, right? So the first thing I'm going to do is this Docker Compose. I'm doing a Docker Compose task, and what I'm going to run is the command build. And you have seen me do this throughout this process. And then after it completes building, I'm going to first start up the SQL Server container. right? And it's going to run Docker compose up. And this -d stands for I just want to have this running. It means detached. It means I want this running in the background. If I were to have SQL Server running in the foreground like I did throughout my demos, this would actually haul up and stall the build pipeline. Then I'm going to run my migration container, Docker compose up migration. And I'm going to run Docker compose up test app. So just as a quick reminder, if I were to look at my Docker compose test, you can see that I do have these 3 containers that I'm trying to start up. I'm starting my database container, then I'm starting my migrations container, and then my test app container. All right. So at this point, it's still running. You can see the live results of what the screen is trying to print here. But let's just go to a previous build so I can just show you the results of what I ran. So if I look at a build, and I could look at the summary. This was built 2 hours ago. I was just doing a final check run before this talk. I could look at the logs. And by looking at the logs, each one of these steps matches that of what I have in my pipeline definition. Right? So you can see here I have a prepare job, initialize the agent. I'm going to get the source, set up the Go workspace, get the dependencies, build all the containers in the test compose file. So if I were to click on this, you can see a very similar output to what I've been running in my terminal, right? And at the end, it says, OK, well, I've successfully been able to build all these containers for testing. And you can see here applying my schema migrations. Very similar to what I've seen in my development environment here. You can see that I have successfully applied 3 migrations to the schema, right? And then I'm running the tests. Similar to my last set of tests that I ran before I checked this in, this is what it looks like, right? So throughout at this point, my development environment, my test environment, as well as having this in a CI/CD pipeline, I've been using SQL Server in containers. I don't have to install SQL Server in my build environment. I don't have to set up in my CI/CD environment. I don't even have to set up in my local dev environment, right? So that's the beauty of that. So let's take a look at the pipeline. It's still running. I think we're almost done. It is currently just running the tests. It'll take about, from this point on, 20 more seconds. But after the pipeline, what do we do, right? So at this point, we can actually proceed to, let's say we finish all the tests, we can actually proceed to check this in. However, the last step that I'm going to do, as defined in my pipeline, isn't just the test. So let's take a look at my Azure pipeline definition. The last thing I'm going to do is I'm going to build a Docker container with this .SQL file. So notice here I have Docker build. And what I am doing here is I am packaging up that .SQL file. And I'm putting it into a container similar to how the Flyway container runs. At this point, I could run this Flyway container against any SQL Server instance with any endpoint, right? And then I'm going to log in. And I'm going to do, finally, I'm going to push this up into my container registry, right? So the last step of the build, actually, it looks like it just completed, right? I can go to my Docker Hub, and because I wanted it to push it to here, I'm going to refresh this page. And you can see that I pushed up a container. On the very left, I have this tagged with my build number, so build number 47. And I have this last updated a few seconds ago. This container contains the change that's required for me to apply to my production environment. So at this point, there's a number of ways in which you can apply this .SQL file, whether you choose to do it manually or through a build process. It's going to work. All right. So at the very beginning of this little section, we showed Flyway containers. We showed how to apply the change and rerun the test. And we were able to check it in into our CI pipeline. And I showed a short demo of Azure Pipelines with this. So let's take a look at the journey of this .SQL file. First, I got this environment, and I discovered the fix. I created the .SQL file. Then I placed this .SQL file into a container, and I applied it to SQL Server running in a container for development environments. Third, I was able to apply this SQL Server with a schema tool to my local test environment, very similar to how I did it for my application development environment. Then I pushed this change, and I pushed my code into GitHub, which triggered a continuous integration process. And my last steps is I packaged this into a container. Right? Now, from this point on, I could use this flyway container with the SQL Server change, and I can apply this anywhere. Right? Now, notice how SQL Server in containers is a critical, is really critical to the journey of this .SQL file and how I used SQL Server containers to really speed up my development time. Where I don't have to install SQL Server instances, and SQL Server is started in a very repeatable fashion. I think that is actually the most important part. Right. So with my last change, let's say I have with my last demo here, let's say I have SQL Server deployed in Kubernetes, and I want to apply this change. Now, I could connect to this SQL Server endpoint. So let me just show you SQL Server running. SQL Server running inside, whoops. Look, so this is my Kubernetes dashboard. It has not been started up. So I'm just going to start up this dashboard so I can connect to it. Give it a sec here. Awesome. OK. So this is a Kubernetes dashboard connected to my deployments I have. And this is hosted in Azure Kubernetes Service. So if I look at an overview and I look at the services, whoops, I can see that I have actually, if I take a step back, I actually currently have 3 SQL Server instances running inside my Kubernetes, all 3 of them joined by availability group. However, it has one service, and you can see that here I have the service. Oops. Here I have in this AG primary. This is my primary instance in my SQL Server configuration in Kubernetes. I could either connect to it with the external endpoint, and this external endpoint is exposed to the public, and most of the time, I actually won't have a external endpoint available. Right? However, for this demo, I have this exposed. Typically, you would only have your SQL Server inside your cluster, not exposed to the internet. Which is why if I want to actually make a change to Kubernetes, to my SQL Server instance running in Kubernetes, I can't just connect to it using the typical the SQL Server endpoint. I would actually have to do this the Kubernetes way. And the way I would do that is, with Kubernetes, is I actually have to apply a job. Right? There's a concept of a job in Kubernetes where I'm going to configure a job, and that job uses a container. So here, this is the YAML definition of what this Kubernetes resource looks like that I'm going to spin up. So you can see that the name, I'm going to call it SQL apply SQL updates. And here, you can see that the image that I want to use from Docker Hub is tigervin ignite apply SQL updates. As a quick reminder, if I go to my Docker Hub, I can see all the containers here. All the containers here. So I want to apply the latest one, or a very specific version of it that has the fix. Right? And then the arguments that I want to apply, because at the end of the day, this is a flyway container. I'm going to pass in the arguments to my database endpoint. And again, this is my external endpoint. Typically, you would have an internal endpoint that this job would run to. Right? And then that's all it takes. Very similar to Docker Compose, that migration service that I had up. So with that said, let's apply this last one. Hope this demo works. All right. So I'm going to go here, and I'm going to put kubectl, which is the command line for controlling, for accessing Kubernetes resources, and I'm going to apply this apply SQL updates YAML, right? And I can see that the job has been created. So if I go to Kubernetes here now, and I look at my jobs, wrong one. Go to my jobs. I can see that a SQL Server updates has been applied here. So again, now let's go back to our production. This is no longer my local host, and let's click enter. Great. So now I went. When the original task was to make sure that these fields were masked, and I went from creating this fix in my local development environment, putting it through tests, through my CI pipeline, and then I was able to apply this to my production environment, which is SQL Server running in Kubernetes. So if I go back to my slide here, so I'll go back to the very beginning where I had my slide. Wow, I realized I had quite a few slides. Okay. I thought I had a lot of demos, but I guess I had a lot of slides too. Okay, session overview. Great. So let's just recap the journey that we took today with developing with SQL Server and containers. First, we went through using SQL Server and containers, and I showed this through Docker Run, right? Followed by doing application development with SQL Server using Docker Compose, where SQL Server was just a component of my application. And then I went ahead and actually showed some testing scenarios also with Docker Compose. And I also talked about applying migrations to SQL Server in containers. And then we also checked in a .SQL file and using SQL Server containers in a CI/CD pipeline. And last but not least, we were able to apply our migrations to SQL Server running in a Kubernetes environment. All right. So now it's time to go back to the end. To my resources slide. All right, which goes to our resources. So if you go to the very first one, we have SQL Server on Linux Labs. There's a container section there that actually shows you how to get a very basic application plus SQL running end to end. Right. So if you were to just take a notice today I used the Docker Compose command quite a bit, and it is a very useful tool. So, in fact, there's a Docker Compose with SQL Server container in the top link. In the second one, this is to get started with SQL Server and containers. So if you haven't done so, I just shown quite a few of the benefits in the session, but that's not all the benefits it has. It has quite a bit more. And with that, if I have any questions, feel free to come up to the mic and ask it. But of course, please do provide a rating. And if my hope is that you took something back that you could bring back to your organization and use on how to use SQL Server containers and how it really helps you. So, thank you. So, if you guys want to come up to the podium, to any of the mics and ask questions, happy to take the questions as well. Could you use the mic for now, and then. Yeah, be great. So first one over there. Sorry. Yeah.
Check. Okay. So I'm new to containers and Kubernetes altogether, so this might be a kind of elementary question. But when you deploy a SQL Server in a container, where is the data stored? So for example, where your actual tables are stored, I have a 1 terabyte data set. Am I going to have a container that's 1 terabyte large, or is there external data source where I'm going to attach that, and then my tables will be available to my SQL Server?
Okay, so the question was, first of all, no such thing as a dumb question. I'll tell you that right now. No such thing as a dumb question. And the question was, hey, where's my data stored, and how's the data component? What is the data component of my SQL Server container? So by default, containers are ephemeral, which means that if the container goes away, the data does as well. However, you could map the data volume to a local volume on your host machine. In fact, what we've seen, let me just go back here and I'll show you. So what I've did in my Flyway application, if you look at the Docker Compose, here I'm actually mapping the volume. So you can imagine on the very left, if you had a directory with all your SQL files, you could map that into your container file, and then on startup time, it will use those SQL Server files in startup. So then you don't have to be dragging or doing a restore of this file, right? So you could persist that data, right?
Actual table data, not just SQL files though, right?
Yes.
Okay. Thank you.
Yep.
So in your example where you had the front end, so you have a web and app, a database, and you're going to spin up a dozen environments for your developers, how do you get the plumbing to be consistent within each one that Web server talks to that, app server talks to that, database server.
Sorry, just to clarify a question, do you mean how do I actually do the plumbing between connect my application to my
Well, you have a script,
Yep,
but if you're going to run it 15 times,
correct.
you want the first one to talk to
Correct,
that
so-
series and the second to the second and so on.
Correct. So to actually run this Docker Compose 15 times and have 15 instances of this, you would actually need, so first of all, you would actually need to change, it would work actually as is without any problems.
You don't have to give it different ports.
No,
or-
because there's a network configured with Docker Compose. For each time you run Docker Compose, there's its own network. So if you look here, so again, let me show you my demo screen, and hopefully this answers your question. So if you look at,
all three containers would be in their own little.
correct. So, but then depending on the external port, that's where you actually have to. So the containers can talk to each other through the internal port. So if you look on the very left, if you look on my screen here, on the right-hand side, this is what the container inside the network is listening to, right? So in this case, notice how the port of my SQL Server, 1500 and 1433, these are different. On my host machine, it's listening on 1500. On my actual inside of my container, it's listening on 1433. This 1433 is accessible by other containers, right? So that doesn't need to change. However, if you have multiple applications running, listening on external ports, this would fail. Docker would complain that, hey, you already have a service listening on port 80. You can't have another service listening on port 80. As an example here. So you would actually have to find a way to have, excuse me, multiple different ports in order to have that connected. And that should work as is.
Okay.
Right.
How you doing?
I guess these are new mics. Yep.
I appreciate the walkthrough you did with the integrated check-in, code check-in, and app test and so forth prior to. I've had some experience with teams, and we do a lot of performance testing in my group. Any tips on how to integrate in, like with VSTS, how you can run load on a particular piece of code or particular segment? Is doing that?
So your question is, how do I run? So then, you're doing performance testing, and you want to have. So are you doing performance testing with SQL Server?
Yeah, primarily, yeah. C++, C# app.
See, so if you want to run test a specific part of your application, just run those set of tests, right?
Okay.
I would just run those set of tests. You don't have to run all the tests all the time, because then you get to a point where you're running a series of tests. And so in my example, I actually ran all the tests in my
Right.
suite. But you can, depending on your application, run a subset of those tests against SQL Server and containers.
Well, more or less kind of a performance profile that you launch when you at the precise time when it's ready to be checked.
That would work.
Yeah. Okay.
But I don't have any specific tips for performance testing in
No,
that case.
not
This would
performance
work.
testing. I just saw the example, and I wonder if there's anything I need to take into consideration with this.
This is totally possible. I would definitely talk to the folks in Azure Pipelines on tips on how to actually test. You could run multiple branches at once to actually test different subsets of your code.
Right.
And they have a demo down there where they can actually show you this.
And I'll probably need to check what gotchas there are as far as actually applying load properly, so it actually simulates. So, okay. Thank you.
Thanks.
Hello, I have one question. It's possible to use integrated security from the application to authenticate in SQL Server running on the containers?
So the question was, is AD auth or integrated security working with SQL Server on Linux? The answer is yes. However, there's a catch. Not working with containers yet. So the challenge here with integrated security and Active Directory is that you actually have to manage key tabs. You have to manage the lifespan of these keys, and if it's expired, it's going to actually have to go talk to the domain controller, right? So there's multiple ways we can do this in a container. We're still defining how this is done, but this is something that we're currently actively working on.
Is it working on the Windows containers?
So it does today already works on SQL Server on Linux. If you go to our docs today, type in SQL Server on Linux Active Directory, you're going to find a tutorial how to set that up.
Thank you.
Yep.
Hi, so I have a question about SQL CLRs. Are they supported in SQL Server?
SQL CLR.
Yeah.
So the question was, is SQL CLR supported in SQL Server on Linux and containers? So there's three types. in terms of SQL CLR, safe assemblies are supported. However, unsafe assemblies are not.
Will they be supported?
So unsafe assemblies are likely, it's not likely to be supported anytime soon because of the security risks that that we've been fixing over the last couple of years. However, we are introducing what's called extensibility models with SQL Server on Linux and SQL Server on Windows, where we allow you to run Python packages, R packages, and Java packages now as well inside of your SQL Server.
What about in Windows containers? The SQL Server in Windows. Windows containers, I mean.
So you could run what I mentioned with those extensibility packages. Those will work on Windows and Linux.
Okay.
But in terms of, to answer your question, in terms of CLR, only safe CLR assemblies are supported with SQL Server on Linux and SQL Server in containers.
Okay. Thank you.
I'll also be at the booth later if you guys have any additional questions or if you guys are working on anything with SQL Server containers, I'm happy to help provide guidance in that area as well. All right. Thank you, everybody.